The session is focused on how urban expansion is measured. There are 4 webinars in the series. The next is on the 7th of October. We hope you'll join us. That session is on explanatory models of urban expansion. A few comments on logistics before we kick off. You'll notice a Q&A function at the bottom of your screen. Please use that function to ask any questions of our panelists during the session. All of the questions will be answered. So if the panelists are not able to attend to your question during the session, they'll be responded to after the fact, and everybody who's registered today will receive answers to those questions. If you have a general comment, feel free to use the chat function. In that chat function, I'll also be posting a link to our newsletter. If you don't already subscribe, please do, so that you can stay in touch and updated on the work of our urban expansion team, and will also receive notice of future webinar sessions. I'll also add our Twitter handle for those of you who are interested in following the conversation that way. As you can see from the earlier ping, the session today is being recorded. It's now my great pleasure to introduce our co-host today, a collaborator and friend of NYU Marron, Richard Lorch. Richard is an architect, a researcher, writer, and the editor-in-chief of Buildings and Cities. Richard, we're grateful for you for co-hosting today. I'll now hand over to you.
Thank you very much, Angela, for that warm introduction. And I'd like to add my warm welcome to everyone here to this webinar. I'm Richard Lorch, as Angela said, the editor of Buildings and Cities Journal. This is a peer-reviewed journal, and it occupies a unique space in academic publishing. It provides a transdisciplinary approach to the built environment and focuses on the interplay between the different scales of the built environment: buildings, blocks, neighborhoods, cities, national building stocks, and infrastructures. So it's a great pleasure and honor for Buildings and Cities to work together with the Marron Institute. This series of webinars explores the quantification and qualitative dimensions of urban expansion, when, where, and how expansion can and should be contained, and when, where, and how it can and should be managed in an orderly, inclusive, and sustainable manner. This will inform a special issue that we're working on with Professor Solly Angel on this topic. And currently there's a call for papers on this topic. We will send out the URL for that later. Today's discussions in this series are on the quantitative measurement of urban expansion, the definition and global measurement of urban extents and their expansion over time. Aerial and satellite imagery are developing rapidly, but we still are far from reaching consensus on either definitions or measurement methods. These measurements, the definitions and numbers, have a large impact on our understanding of how cities change and the subsequent allocation of political and financial resources. I'd now like to introduce Gilles Durantin. Gilles is the Dean's Chair and Professor of Real Estate at the Wharton School of Business at the University of Pennsylvania. He is the guest co-editor of a 2021 special issue on urban delineation in the Journal of Urban Economics and co-author of Delineating Urban Areas Using Building Density. Over to you, Gilles.
Okay, let me make sure I'm not on mute first. Thank you very much for this nice introduction, Richard. Let me introduce very quickly the other speakers and discussants today. So the first speaker will be Juan Fernando Vargas. Juan is an old friend of mine. He's professor of economics at the Rosario University in Bogota, Colombia. Juan got interested in the subjects of urban delineation when he was working for CAF, a development bank in Latin America. And eventually that led to a paper that's forthcoming in the special issue that I'm editing. He's going to tell us about nighttime lights and using that to define cities. Patrick Lamson-Hall is a research scholar at the Marron Institute of Urban Management of NYU. He manages the India Urban Expansion Observatory in Mumbai. He is also a co-author of the Atlas of Urban Well Expansion, with a final speaker, Solly Angel. So Soli is a professor of city planning at NYU's Marron Institute of Urban Management. He's a major figure in that area. He's authored many books, including most recently the Atlas of Urban Expansion and Planets of Cities, together with the Lincoln Institute of Land Policy. The second discussant with me is Anne-Marie Schneider. She's an associate professor at the Nelson Institute of Environmental Studies at University of Wisconsin, and she's also worked intensively on global urbanization using satellite data. Should I start next with the rest? Okay, so I was asked to provide a broad introduction to the subject. So let me tell you what I think about all this and why I think we need to take this subject well seriously. So I think, there's a tendency to delineate cities for the sake of it. At some level, yes, we need those popular numbers. Whenever we go somewhere, my kids always ask, how big is this place? How many people live there? Whatever that may mean. But at the same time, I think for us, we need to know what we're looking for and what we need this definition of cities for. So, it could be you want to isolate or you want to separate rural areas for rural policy, and that's a perfectly reasonable goal. In that case, that may mean actually you want to have a reasonably extensive definition of what's urban, so that actually what you're going to look at being rural will truly be rural. You may be in charge of building a transit network, and for this you want to reach actually the whole metropolitan area, the whole city. That's one possible objective. Closer to what this seminar is about, we may be also about housing expansion, trying to understand where housing needs to be built next, and so on and so forth. Maybe this calls for a slightly more conservative definition of cities. You may be studying local labor markets, either as a researcher or as somebody with more direct policy interests, and that may beg actually for yet another definition of cities. Part of my research is about urban transportation and congestion. And I also want to take a reasonably narrow definition of cities, because if I'm looking for congestion, I'm not going to find it most likely 80 or 90 kilometers away from the center. I actually want to measure congestion where it's taking place. You may be concerned with public good provisions and so on and so forth. So you need to know what you're doing and why you want to do that. And then you also need to have a conceptualization of what is a city. A city, I guess, in Soli's mind, quite a bit for me as well, and clearly in Alamberto, who's a famous colleague of Soli, the city is a labor market. But, we may also be of the opinion that it's just a group of people living together to conduct a variety of interactions, including sharing local public goods and so on and so forth. A last possibility, which sounds a bit stupid, but actually is not, is given how difficult this is to define a city, maybe we should actually define a city as, like Humpty Dumpty, a city, I know it when I see it. So that sounds a bit extreme, but today actually there's one paper in the JUE special issue that's taking this idea pretty seriously, actually asking people to look at satellite pictures of places and say, okay, how urban is that? And then processing a pretty large sample, and then actually doing machine learning to process the rest of India. That's a possible approach as well. So we need to have both a reason for doing this delineation and a conceptualization of cities. I think that will become clear why this is actually so important and why we may reach actually such different results. Then, depending on, there are two broad approaches to defining cities. Either, again, this is something where people are next to each other, so it's typically build up contiguity and, stuff that is close to each other, and you try to draw the line somewhere around that. But if you think a city is a local labor market, in that case, you probably want to look at commuting flows. I understand that commuting flows are difficult in two ways. The first one is they're not very often available, so they I've worked with them in Colombia, I've worked with them in France, but I understand it's not everywhere. Then the other issue about commuting flows is that they're discrete flows, and when you go like micro, you know, you have this flow from this person living in this little neighborhood to that other person. How can you use those flows to define actually and to group space together? It's actually quite difficult. Second important question when you define cities, do you want to take an absolute definition of a city? You know, like what Soli is going to present, where a city is this, it's at least 50,000 people and at least this level of density, blah, 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 blah. Or do you want to take a relative definition of cities, thinking, okay, it's relative to some region around or some country around, maybe a group of a country. It's a peak of population or built-up density. The problem with absolute density is that, as we will see, we reach some results that seem counterfactual, where India, by some metrics, is more urbanized than the US, which at some level I think is wrong. Absolute definitions, again, if you go back to 1700, you know, there was only one city in England by some definitions. That's probably wrong, and so on and so forth. So there's no clear answer to that. Again, what do you want to do? Why do you want to do it? People use all sorts of metrics, so flows, people, build up, light. So we'll see some illustrations of that. I'm seeing two big problems in that issue, in that problem of delineating cities. Well, to finish, problem number one, as you will see, people need to make all sorts of assumptions and typically use thresholds, and those thresholds are just plain arbitrary. I think the name of the game, and this is what I've tried to do in my own work, is actually to reduce the arbitrariness of those definitions, rely maybe on statistical threshold as opposed to just arbitrary thresholds of population. Second problem I see in that issue is there's a big gray zone of, you know, there are lots of areas at the urban boundaries which, you know, urban economics is predicting that there should be those reasonably flat gradients of declining population density. And depend, you know, it's not clear where you should be drawing the line. Should you be more conservative? Should you be less conservative? That can actually make a huge difference in terms of what you're going to define as a city in terms of area, and a smaller difference in terms of population, because those areas are not the most densely populated. So I think this is what we're going to see at play in the next three presentations. So let me stop here and hand the floor to Juan Vargas.
Thank you so much, Jill, for the introduction and for this kickoff that is interesting. I will start sharing my screen. So if you just give me a second. Can you see the screen? Okay, yes. Perfect.
Yes.
Thank you so much. Okay, so thank you for the invitation, and Soli and colleagues that are organizing this webinar. So I'm going to present, you know, a little bit of this idea of measuring the size of cities using nighttime lights. And as Jill said, this is a paper that sort of sets the stage for thinking about this idea. It's not the ultimate answer of this. And as Jill said, doing this type of stuff you know, relies on some assumptions and stuff like that. So there's a lot of research that can be done further after this. So this is a paper that is forthcoming in the Journal of Urban Economics. It's a special issue that Jill edited and is co-authored with Rafael Che from Princeton and Diego Martin from Purdue. So essentially our approach in a nutshell starts with the fact that nighttime light has been shown to be a reliable proxy for economic activity, even in very small areas. So there's a lot of evidence of this, not only in economics, but in sort of remote, in the remote sensing literature, in political science. And there's, building evidence on this. And the seminal paper is a paper in 2011 by Vernon Henderson and co-authors. And the second observation is that economic activity is precisely at the heart of our conceptual understanding of a city, right? I'm not going to sort of debate what's a city conceptually, but in most definitions, there is going to be this element, which is the spatial integration of social and economic activity, right? So that translates into labor markets, that translates into commuting patterns, buildings, etc. So if you put these two things together, it means that probably by using sort of spaces as measured by nighttime lights, you could sort of delineate cities, and this is what we do in a nutshell. So specifically, we just follow 3 steps. The first step, and this is going to become a little bit technical, but I'll try just to make it broad and not very boring. So the first step that we follow to delineate cities using this approach is just identify urban cores. And in our case, we're going to identify potential urban cores of more than 50,000 inhabitants, or at least 50,000 inhabitants, because we need some sort of threshold of what a city is, but we could play around with this and make it different if you think that cities also should include like smaller towns, or we could move it up if you think that cities are actually bigger than this. So this is arbitrary, but it can be changed. So this is because we need to identify where the potential cities are located. So this is because you see images of the entire world from satellite pictures at night, but you need some sort of you need to circumscribe these nighttime lights into particular areas of interest in which there might be cities. So for that, we follow 2 approaches. First, we use from the global urban settlement population grid cells of more than 300 people per square kilometer and over 50,000 inhabitants in total in that cluster. And then with that, we locate that core's centroid. And we complement this approach, which is very data-driven, with the universe of cities that have been pre-identified by the Atlas of Urban Expansion, which Jill mentioned and Solly and his co-authors did. So the second step is that we clean and process the nighttime light data. So nighttime lights have several sources of measurement error that have been identified by also a broad literature, and these include but are not limited to degradation of the sensors of the satellites that take the pictures, blurring in the sense that nighttime light overglows, the misalignment of between and within satellites, so the misalignment of 2 satellites that take the same picture and are misaligned, or the missile of one satellite that takes the same picture twice, but in the second time is not totally aligned with the first one. So these are things that make the use of this data, this raw data, complicated. So what we do is that we use existing methodologies and existing corrections and insights from the remote sensing literature to clean these images, right? So what we do is just we create an algorithm that uses many insights of methodologies already implemented, and apply them all to have a very clean sort of input. But we do not propose any new method per se. We just organize these things into one algorithm. And the third step is that we use with the process pixels of light to identify the extension of cities. So what is a city for us? Is a spatial conglomerate of at least one square kilometer. It's a spatial conglomerate, sorry, of 1 square kilometer nighttime light pixels, because these pictures, at least until 2014, come at a definition that is of 1 square kilometer. So these are pixels, and we take the conglomerate of these pixels that are built around deeply identified urban core in step 1. From that, we clip large water bodies like oceans and big lakes, for instance. But this aggregation, this conglomerate of pixels, it presents some challenges. One of them is that some of the nighttime light pixels are unstable, which means that they, in the same spot on Earth, they don't appear all the time. So it's kind of on and off. So you need to impose or not, if you want, but probably you need to impose some sort of threshold of stability. So we do that, and we show the robustness of our results, so imposing different stability thresholds from 0 to 50%. So it means that at least in 50% of the pictures that the same satellite takes, the nighttime light pixel needs to be lit. So you can play around with that. And the second thing that we do is that for comparability with other data sets, we have to sort of cut some estimated metropolitan areas. Let me explain what that means. It means that since we're taking a very data-driven approach, which is the extension of corrected pixels of nighttime light, turns out that you could define, from that approach, you could define the sort of big area of the east coast of the US, connecting, for instance, New York and DC. Sort of between New York and DC, there are like continuous urbanized settlements, in a sense that makes these two cities connected in an urban way, right? So if you look at nighttime lights, after the blurring and after all the connections, this is one big city, like this corridor, like starting in the south in DC and going all the way up to New York in the north, right? So in some sense, if you want to compare the number of cities, for instance, in the US with other approaches like the US metropolitan statistical areas or the Atlas of Urban Expansion, you need to cut these big metropolitan areas, and for that we use we split according to the width of the connecting urbanized corridor that comes out in the nighttime lights. And these are not highways. This is actual people living there. Okay. Again, you can just set the threshold at 0 and just count this as a one big city, but then it would be less driven by assumptions, but then it becomes less comparable to other data sets. And how do you call this city that is, it puts together New York and DC? So the resulting database is a worldwide georeference database on the location and area of metropolitan areas of at least 50,000 inhabitants. But as I said, you could use the same methodology and to change this threshold and put it bigger or lower. In 2000 and 2010, because this is what we did for the paper, but you could apply the same methodology for every year for which data on nighttime lights is available, starting in 1992. The exact number of cities depends on assumptions. We provide 15 estimates depending by varying these two assumptions regarding pixel stability and the split of contiguous metropolitan areas. And then you can overlay this, of course, with existing georeference population data sets, of which there are several, and then estimate urbanization rates and city densities. So there are pros and cons, of course, of this approach. The first, as I said already, luminosity has been proven to be a reliable proxy of economic activity. So it allows us to identify clearly integrated markets, economic markets, labor markets, etc. it's you can with this do comparable analysis of satellite facts about urbanization across different regions and for the entire world, and then compare urbanization or correlate urbanization with income levels without relying on sort of heterogeneous and country-specific administrative definition of cities, which is useful. We don't have any ex-ante population threshold, or density threshold. We don't have any assumption on how people move, as GL said that he has done for France and Colombia. But we do, in terms of we do have assumptions about pixel stability and metropolitan areas, the split thresholds. But as I said, we showed the robustness of our results to changing these assumptions. And finally, there is relatively low computational demand. Let me just jump to the maps of 3 cities that I was asked to do using our data: Dhaka, Luanda, and Warsaw, and we do that for 2000-2010. So essentially, what I have here is first Dhaka, and then I have the red perimeter is the limit of the city according to our methodology in 2000, and the blue one is the limit of the city according to our methodology in 2010. So you see that there's not much growth of Dhaka, in this period, and we overlay that with both Google Maps and Google Earth for reference in terms of first what Google Maps actually thinks Dhaka is, and second what Google Earth shows in terms of sort of patterns of colors that you could see where the city is. I'm happy to share these slides so you guys can have a closer look at it, but I have to move on. So now Luanda, in contrast to Dhaka, grew extensively and moved away from the water body into the southeast and northeast. So you see that there's an extensive growth of Lusaka between 2000 and 2010, and that's sort of consistent if you look at the Google Earth image, which is the current one. It's sort of consistent with the pattern of colors that you see there in the right-hand side map. And finally, Warsaw also grew a little bit more in most of its perimeter, especially in the southeast and in the north. Essentially, this is what we find for these 3 cities in terms of like the extent of the city at the baseline, which is 2000 in our case, and its growth all the way into 2010. And finally, I'm going to finish with sort of our estimates, given this methodology, our estimates of the growth rate in sub-Saharan Africa and the world in terms of area population density. And please bear in mind, before we look at the figures, bear in mind that you can have very different estimates depending on how you vary these thresholds that I mentioned, right? So we have 15 different versions of the data set, and what I'm using here is a stability threshold of 20%. So the same nighttime light pixel needs to be lit at least 20% of the time for us to count it as urbanized. And we're on a 5 kilometer threshold for the width of the connecting corridor of 2 different metropolitan areas. So with those assumptions, we find that in sub-Saharan Africa as a whole, the area of cities above 50,000 inhabitants decreased a little bit. It's probably if you put standard errors in here, it's probably not significant. And I apologize for not doing that. The population, in contrast, the urban population, according to our methodology, and of course, relying on the population rasters, which has for the assumptions that are not imposed by us, but by the people who do these population data sets. The population grew in these cities grew by 23%, and population density therefore grew by 24%. In the world as a whole, the area in cities of 50,000 or more inhabitants grew by almost 40%. Population also grew between these, like in this 10-year period, grew by almost 10%. And because area grew more than population in the entire world, population density fell by about 20%. And this is consistent with the sort of observation that cities are becoming more suburban in many parts of the world lately. As I said, this stops in 2010 because this is where we did for the paper, but you could do this, apply the same methodology with the same satellite night time pictures until 2014, and then with the new set of satellite pictures up to now, if you want. So that's it. Again, thank you for the invitation, and thank you for listening and for your questions, which I'm going to look and address. Thank you.
Okay, thank you very much, Juan. Our next speaker is Soli Angel. Soli, you're on mute.
I'm mute. I think that Patrick should speak before me.
Okay, I was instructed that you should be next, but Patrick, if you want to go next, that's perfectly fine by me.
For me, this is fine. Thank you, Gio. And thank you as well for your introduction. I think that was very nice. And Juan, excellent presentation. Really a pleasure to see a little bit under the hood on how that methodology works. I know that there's a desire not to be too detail oriented in these things, but for me, as literally as a professional nerd, it's great to hear about thresholds and all those kinds of things. So I'm going to share a presentation on the NYU approach to measuring urban growth. Let me just get this up. Good. Is this looking reasonable to everyone? Ah, wonderful. So a little background, I think Angela gave this. The Marron Institute has a program that's focused on urban expansion, and the major initiative that we've pursued under this program is trying to assist municipalities in preparing for urban expansion. So we come to the activity of measuring urban growth with an eye toward that objective, which is really oriented around trying to estimate how much land cities are going to consume in the future as a way of assisting them in preparing simple plans for managing their urban peripheries. So that's sort of our lens on it. So we've been asked to answer 3 questions: how the method delineates cities, how we map the expansion of 3 cities, and then average annual rates of change in sub-Saharan Africa and in the world at large. So to start with how we delineate cities, the method that we use to delineate cities is called the NYU urban extent. And the NYU urban extent, as you can see here, measurements for another set of cities. What it allows us to do is to measure the change in cities over time. And what it focuses on is the unit of analysis. The unit of analysis in this exercise is the city. And when we talk about the city, we're talking about an area of built up pixels, in this case, kind of buildings and impermeable surfaces. And those built up pixels have to cross a certain threshold in terms of their density. So there has to be a certain concentration of built up pixels in an area in order for that area to qualify under our methodology as urban or suburban. And I'll get more into the details of how that works, hopefully not in a way that's plotting, but the core assumption behind that, at least as I've always understood it, and I see that Soli's not on mute, so there's a risk that I may be amended in some regard, but my understanding of this is that obviously our focus on cities is as metropolitan labor markets, but more importantly, as spaces where learning and matching can occur for workers and where economies of scale can occur for firms. And so what that means is when we're using the built up pixels, you might think of the built-up pixels as a proxy for those things. And what the built-up pixels represent is actually an intensity of physical capital. So what we're mapping is we're mapping physical capital that's been constructed on the ground, and that this in some way reflects the higher productivity that's obtained in a city when learning and matching and economies of scale are functioning well. And the area that we're measuring as it changes over time, you might think of as kind of the surface area that's participating in that activity of having this urban productive benefit. So that's sort of our basic theoretical assumption. And the nice thing about this, similar to the nightlights method, is that it lets us sidestep questions of population and population density, which we know vary a lot depending on factors that aren't necessarily relevant to the question of labor markets, things like household size or the availability of land for development in the country. So with that, I'll go into the technical details a bit. Our inputs, we typically do this activity using Landsat imagery. We've recently been exploring doing it with Sentinel imagery, and in theory, there's no reason why you couldn't. It needs to be cloud-free, so we're typically using mosaics. We use the lat long of City Hall, which varies from place to place. The idea is to get a point that signifies where the center or where some part of the city is, that lets us know where to start our analysis. And then a study area boundary. The study area boundary typically is related to the population data, because our analysis also includes trying to incorporate some sense of what the population is once we've identified the urban extent of the city. So we look in Google Earth, usually roughly identify boundaries that appear to encompass the extent, and then do a guess and check revision method to get boundaries that actually correspond to the urban extent as we measure it. So if we're classifying the urban extent and it turns out that we didn't include enough enumeration units or aerial units, then we add more until we find kind of the natural edge based on our method. So the first thing that we do is we identify the built-up area pixels. We do that taking these 30-meter Landsat pixels and classifying them through supervised classification into built up, not built up, and water. Built up here delineated by the gray, water by the blue, and not built up by the tan. And so this is Bogota, which I'm going to use as an example. Bogota in 1990, this is what we get when we identify built up, not built up, and water. The next thing that we do is we try to characterize these built-up pixels. And the way that we characterize these built-up pixels is by measuring the density of other built-up pixels around them using something that we call the walking distance circle. So we take a given built-up pixel, and essentially what we do is we measure how much built-up area is in its neighborhood, which is a circle with an area of 1 kilometer, a radius of 584 meters. We count all the pixels that fall within this area. And then how we characterize the study pixel is based on the proportion of built up to non-built up pixels within the circle. So I'll show you how that looks in the case of Bogota in 1990. First, we identify urban pixels. Urban pixels we consider to be those that have 50% or more built up pixels within the walking distance circle. So have to have at least 50% or more, and those would be these red pixels. Then we have a second tier, which are called suburban pixels. Those are pixels where between 25 and 50% within the walking distance circle are built up. And you can see that this maps reasonably well. So in the core urban areas, naturally you get urban pixels. On the fringe areas where you would encounter a greater number of not built up pixels, you get suburban pixels. Then finally, we have rural pixels where less than 25% of the pixels in the walking distance circle are built up area. And those are these orange kind of outliers here. Then we talk about open space, because as we know, cities don't just consist of built up pixels, they also include open spaces. And there's a literature, it's in the ecology literature, about the impact of urban areas on adjacent open spaces. So first we catch the fringe open space pixels, which are all of the open space pixels within 100 meters of urban or suburban. Then we look at captured open spaces, which are those that are fully contained by suburban, urban, or fringe open spaces that are less than 200 hectares in area. So that gives us these areas. Then finally, we characterize the rural open space, which is all the other open space pixels within the study area. So that is how we address the differentiation of the built up and open space pixels. Next, we want to identify the urban extent. So the urban extent requires us to make a boundary that says, this is part of Bogota, and this over here isn't part of Bogota. We do that using a cluster-based analysis. And this is where our CBD or city hall point comes into play, which allows us to identify the primary cluster. That would be the one that contains the city hall, or in the case of Chinese cities, we use the office of the Ministry of Security, for example, as our point. That lets us identify the primary urban cluster indicated here. And then we identify the other urban clusters as well that are in the area. So they have to contain urban pixels, which is why this little fella isn't in there. Then around the primary cluster, we create a buffer with an area that's equal to a quarter that of the primary cluster. And the urban extent is going to include all the clusters that fall within that buffer. So in the case of Bogota, that's this one, and then the primary one in 1990. So you end up with this map of the urban extent that includes contiguous and non-contiguous built-up pixels within a certain area. Now we repeat this exercise over time. We can see the urban growth that occurred in this, as I say, the city is the unit of analysis. So within this city of Bogota, we can see the growth that took place between 1990 and 2000. And we can map that and the urban extent that results from that. And between 2000 and 2014, again, using later Landsat imagery, and we can see the urban extent that results from that. And when we layer these urban extents over each other, you get a map like this, which shows the area of Bogota in 2000, or in 1990, in 2000 in the orange, and in 2014 in the reddish brown. And you can see how this city of Bogota has expanded its area over that 24-year period. So this has parameters, arbitrary parameters, as has been pointed out, as many of these methodologies do. I'm sure that you've caught most of them, but I'll flag them just for the sake of academic integrity. A major arbitrary parameter is the area of the walking distance circle. Now, we have experimented with different walking distance circles, and it turns out that the resulting urban extent is not as sensitive to it as you would imagine. But it is a decision that we had to take about what is a reasonable area of analysis around a pixel. The ratio of suburban to urban pixels, the ratio of built up that gives you suburban, urban, or rural. We set for urban, we set it at 50% of the pixels in the walking distance circle have to be built up. This is arbitrary. This is something that can vary as well, and you can conduct sensitivity analysis around that to see how different thresholds affect the urban area. Because we ultimately end up grouping urban and suburban pixels, it turns out that the sticky threshold when it comes to the ultimate reach of the city is actually the rural pixels, where you start the cutoff for the rural pixels. And what we found in our research, especially in Colombia, where there are a number of smaller cities and where the cities tend to be pretty dense, what we found is that the rural cutoffs sometimes have to be changed in order to capture all of the area that's considered to be urban by the municipality. So this is something that's subjective. Then when we're talking about open space, we choose a 100-meter buffer for how to characterize the fringe open space. Again, this is supported by the literature, but it could as easily be 75 meters or 125 meters, and that would affect the area of the urban extent in some small way. Finally, the inclusion rule, where we make a decision that says we know that cities contain areas that are non-contiguous. How do we want to capture those areas? Well, we choose to use a buffer around the primary cluster, and we choose an area that's equal to 25% of the primary cluster. Again, that could as easily be 35%, 50, 100, or 10. And that would affect which clusters were included in the final urban extent. So this is another area where there can be sensitivity analysis conducted. When we use this methodology, because we're treating the city as the unit of analysis, we can create a number of metrics. We can calculate the values for the pixels in the urban extent, the open space pixels, by combining population information, we can calculate density of population. We can also calculate density of built up area and city footprint. We can say something about the ratio of open space pixels to built up pixels, which we call saturation. We can talk about openness, compactness of the shape form, and also we can study the composition of the added area, whether or not the growth of the city is taking place mainly through the addition of new built up pixels within the existing urban extent, or through new built up pixels being added on the periphery, or through leapfrog development, non-contiguous, or through the incorporation of settlements that previously existed but weren't within, say, the area of influence of the city. So we can conduct that analysis as well. Moving on to the second question, how we map the expansion of these three cities, Dhaka, Luanda, and Warsaw. So starting with Warsaw, we have the 2000 area in this kind of ketchup red and the 2014 area in this mustard yellow. And we can see that Warsaw grew along its arteries, and that the area expanded by our count from 56,000 hectares in 2000 to 74,000 hectares in 2014. The population grew much more slowly, from 2.12 million to 2.29 million in 2014. And because the rate of expansion in the area of the city was more rapid than the rate of expansion in the population, the density declined from 38 persons per hectare to 31 persons per hectare. Looking at Luanda, so we see extensive growth in Luanda between 2000 and 2014, both in terms of area and in terms of population. The area more than doubled from 23,000 hectares to almost 50,967 hectares. The population also more than doubled from 2,690,000 to 5,555,000. So this is a very rapid rate of increase, both in the area and in the population. And the area expanded slightly faster than the population. So the density declined slightly from 116 persons per hectare to 109 persons per hectare. Finally, looking at Dhaka. So we see Dhaka growing along its periphery, of course, extending along the existing road network as well into rural areas. In the year 2000, we see Dhaka having an area of 22,825 hectares, which grew to 36,541 hectares by 2014. And much of that growth consisted of these areas to the north, and then the filling in of this area down in the south. At the same time, we see a massive increase in the population from 6.69 million in the year 2000 to 13.6 million in 2014. And so what we see when we look at the density of Dhaka, because we see the population increasing much faster than the urban area, is we see an increase in the density from 293 persons per hectare, which incidentally was already like world-leadingly high. I mean, that puts this city in probably at least the top 20 for most dense worldwide, to 372 persons per hectare, which, if I'm not mistaken, is probably the most dense major city that we studied. So increases in density when you don't see consummate increases in urban area, that's what occurs. Moving on to the third question, average annual rates of change of area, population, and density of urban settlements in sub-Saharan Africa and the world. We mapped this from 2000 to 2010. So looking at area, we see a 4.41%. And I think I did this slightly differently than Juan, because I was looking at the annual rate of change. So 4.41% increase in urban area per year in sub-Saharan African cities of 100,000 people or more, with the kind of an error confidence interval here. And then in the world, 2.99. So in both cases, we see expansion in the area faster in sub-Saharan Africa than in the world at large. Looking at the growth rate of population, in sub-Saharan Africa, we clock the rate of population growth at 3.75% per year over this 10-year period, again, with a confidence interval versus 2.32% per year in the world at large. So as with the increase in area, we see that the increase in population was faster than the world at large. Now, the third question about density, you should probably already know the punchline here, because the area was growing at 4.41, the population was growing at 3.75, you know you're going to see a negative number when it comes time to talk about the density, because if the area is growing faster than the population declines. So we measure that decline at negative 0.65% per year with a healthy confidence interval, as against a global decline of negative 0.67% per year, indistinguishable. I guess that's all I have to say. So we have more rapid increase in area, more rapid increase in population, and a decline in density that we can't distinguish from the world at large. Thank you.
Okay, thank you very much, Patrick. That was great. Our third and final speaker will be Soli Angel.
Thank you. Let me share my screen. Yes, thank you. Okay, I'm going to talk about delineating urban areas and estimating urban expansion using the European Commission degree of urbanization, also called the Gerber Method. This is not something developed by us, but by the European Commission. We've asked the people at the European Commission to make the presentation, and they declined. We will be collaborating on comparing these methods later. In the meantime, I will give the best interpretation I can of their method. Next slide. So these are the three questions. We went through them. Let's start with the first question. Next slide. Okay, how does the degree of urbanization that the Gerber method define cities? Next slide. So we start out in the same way that the NYU method, we start out by looking at 30-meter Landsat imagery, in this case for Bangkok, Thailand. Next slide. We use a machine learning algorithm to classify this 30-meter Landsat pixels into built-up open space and water. Now that method attains a certain amount of accuracy. The overall accuracy in 2014 was 71%. It has now slightly improved. And this is a machine learning algorithm, namely, they insist on not correcting it by experts, even when there are observable errors. And then they aggregate the data to create a 1 kilometer square grid, which is called Global Human Settlement Built Grid, identifying the percentage of built-up area pixels in each grid. So this is what you see in this slide for Bangkok. Next. Okay, then separately, they look at the population, they create a population grid. They collect the available data on the population of census enumeration districts, which is collected globally by CSUN at Columbia University, that publishes its Grid Population of the World project. It's already in its fourth presentation. And then they look at these enumeration districts and they map them into a 250-meter grid, dividing the population within each enumeration district into the cells in the grid. Next. And the way they do that is they, for each enumeration district, they identify the share of built-up pixels within each 250-meter cell within that grid. And they allocate the population of that enumeration district equally according to the share of built-up cells in each cell, so that the cells with more built up get a higher share of the population within that enumeration district. But they assume that every built up cell has got the same density. So they allocate these things equally among each of the built up pixels. And then that leads to the construction of a 1 kilometer global human settlement population grid, which is what you see here. So that now tells you what is the population in each square kilometer. Next. Okay, now, depending solely on the population of these grid cells, they classify these into settlement types. And the settlement types are based on cell contiguity, namely two contiguous cells, along the edges, contiguity along the edges, not along the points. And they look at contiguity, density, and total population within clusters of contiguous cells. And they look at the share of built up areas in these cells to create a global human settlements model. Next slide. I'm not going to look over this slide, but specifically, the urban center is what is the focus of this presentation. The top line are contiguous cells with density of 1,500 people per square kilometer or more, a population of 50,000, and each cell has a threshold of 50% built up to be included, or a cell density of 1,500 people per square kilometer, and the distance to the other clusters is more than 3 kilometers. All of those are urban centers. By the way, to distinguish from what Patrick was talking about before, urban centers are only one contiguous area. They are not combinations of clusters. They are a single contiguous area. Now, the other three types of settlements, dense urban cluster, semi-dense urban cluster, and suburban and peri-urban areas, are also urban areas, but they're not part of urban centers. They include suburban and peri-urban areas, which are cells with lower density, 300 people per square kilometer, and cluster population of 5,000 or more, and the built-up area threshold of 3% or more, and that they're less than 3 kilometers from other clusters. The rest are rural clusters. So just so when you look at this table, keep in mind that urban centers are the key way that they define cities. And next slide. So when you see here is the resulting analysis for Bangkok. So the red one is the urban center of Bangkok. The yellow on the periphery are the suburban pixels, but they're not included in the urban center. And the urban centers are then used to create an urban center database that has information on all urban centers in the world, that 13,133 cities that had contiguous urban footprints with 50,000 people or more in 2015. The database provides data on population, area, and density for these cities for 1975, 1990, 2000, and 2015. Next slide. Okay, the main contribution is that this method provides a uniform definition of urban settlements for all countries, overcoming the limitation of the World Urbanization Prospects estimates, which, because of UN mandate, must use the unique definitions of each country as to what constitutes the urban. And then the methods extends the urban-rural dichotomy into a tripartite degree of urbanization that distinguishes urban centers, typically dense cities with 50,000 people or more, from smaller, less dense urban clusters, including suburbs and peri-urban areas. The methods provide new data, both maps and metrics, on all settlements the world over at no cost to users, which can now be updated every year with the use of higher resolution satellite imagery, namely Sentinel. Next slide. Some of the limitations of this method is the density threshold for urban settlements, which is 300 persons per square kilometer, roughly equivalent to one house on an area equal to 2 soccer fields, is rather low, resulting in very high estimates of the urban populations of countries. The definition of urban, by the way, is solely based on density and population of settlement clusters, ignoring employment in agriculture, for instance, as evidence of a settlement being rural and not urban. That also results in high estimates of urban populations of countries. But these two parts of the method, in Angola, according to this method, was 82% urban in 2015, yet according to the ILO, 51% of its workers were employed in agriculture. Bangladesh, according to this method, was 89% urban in 2015, more urban than the US and most countries in Europe. Yet, according to the ILO, 43% of its workers were employed in agriculture. Third, the urban center database, both its maps and metrics, does not include suburban and peri-urban areas as integral parts of cities, resulting in an overemphasis on the denser, more central parts of cities, and thereby underestimating urban expansion. Another limitation, which I didn't write down here, is that it's not clear whether the data on the built-up area of urban centers in the earlier period were just the built-up area within the 2015 urban footprint, or was it the area of urban centers within this urban footprint? It's not clear, and that makes it harder to assess whether too much area or too little area was assigned to that urban center in the earlier period. Next slide. I now look at question 2, the 3 cities. Next slide. I just want to point out here that the population of Dhaka increased from 14.9 to 23.9 million. Those numbers are much higher than the numbers that Patrick presented, which is 6.9 to 13 million, and its average density increased from 18.6 to 27.6. A lot larger area is considered to be Dhaka than both methods presented before, because the dense rural population around Dhaka gets incorporated into the Dhaka urban center. Next slide, please. Luanda increased its area from 468 to 771. The population increased from 488,000 to 6.8 million. Again, the 488,000 is clearly an error, but because it was generated and because they don't correct errors with experts, this this information remains there. So that means the density increased 14-fold, but that's clearly not what it's meant to be. Also, you can see quite a few suburban areas outside the urban center that are not considered part of Luanda. Next slide. Warsaw, the population didn't change, and the area increased from 374 to 425. So density slightly declined. Next slide. Okay, now I look at the third question. Next slide. Okay, the average values are for urban centers associated with named cities. I omitted information from the suburbs and peri-urban areas. The average values that are reported here were calculated for 10,000 urban centers, for which there was data for the year 2000. and 1455 urban centers in sub-Saharan data for which there was data again in 2000, 2015. The average annual growth rates we're calculating by first calculating the annual growth rates for each urban center and then calculating an overall average for the world and for sub-Saharan Africa. This has made it possible to calculate standard deviations and confidence levels for these average values. Next slide. So in the word, we can see the urban center population grow by 1.2%, and the sub-Saharan by 2.5%. Next. And the area for the world grew by 3.2%, and for sub-Saharan by 3.4%. Clearly both, next slide, higher. So in sub-Saharan Africa, in the world at large, we see a decline in density about 0.5% per year. Not much different than what Patrick was showing. In sub-Saharan, we see an increase in density of 0.8% per year. Next slide. Thank you. That completes my presentation.
Okay, thank you very much, Soli. That was great. So Anne-Marie Schneider will be the first discussant, but I would like to encourage also a member of the audience to start using the chat to raise their questions to the presenters. Anne-Marie, the floor is yours.
Great, thank you so much. These were incredible presentations. I want to thank all the speakers and thanks for having me here to discuss some of the issues. An amazing amount of work went into all of these different maps. And so I'm like Patrick, I really like seeing all the details because it really helps me understand what's going on in the background and what assumptions are being made. Because I think, like Gilles said in the beginning, this is kind of the key to understanding why we haven't reached community consensus. So when Soli first started talking and he was mentioning, we don't quite have that community consensus yet on the definition. Why are we all here? And I think it was Angela at the beginning as well, who mentioned, you know, there's so much interest in this, how we're defining urban areas, how we're defining urban expansion. And there's this laundry list of all these different things that we measure with cities. And I would argue we actually need all three different types of data, right? We need nighttime lights data. It tells us something about the economic activity. We need that land information and land expansion. And I think we're reaching a community consensus on using Landsat data, using Sentinel data, that these sources are out there. And we started to master how to actually capture urban areas in those data sets fairly well. But then the population data comes up as well. And we are kind of leaning towards this metric, and it was brought up in all of the presentations, of built up land as opposed to or divided by the number of people. That's kind of this guiding metric on density that I think is useful and that we can pull from all of these presentations. When you have that metric, that sort of built up area versus number of people, there's sort of the considerations of the data going into those and the methods, and I'll talk about that in just a second. But then there was a second step in all of these presentations that I thought was really interesting. And that is, all right, we have these cities, we have, whatever data we've used, we've laid out the urban extent. But then, as Patrick articulated really, really well, what measures can we use to define what's a city, what's a cluster, what are the densities, how that city is growing in terms of cluster, or maybe it's growing up, maybe it's growing outward. And so these sort of after the fact, after we've measured the city, then how are we going to put some labels on what are settlements, what are clusters, what should be considered urban versus rural? And that kind of, to me, that's a separate set of issues. And I love the conversation that goes on about those measures. But ultimately, I think it comes down to what data is going into it. And so I'm going to go back to my considerations there. First of all, like I said, for urban extent, I think for using Earth observation data, we've come so far in terms of how we define a city. And we have these thresholds, and we've done some sensitivity testing in my own group as well on how sensitive things are to that threshold of 50% built up, what's built up within a pixel. And we have that sort of arbitrary pixel unit as well. the one consideration I want everyone to think about there is that our pixel size is also arbitrary, that 30 meters. And our pixel size is changing. We have better and better data sets coming online, and that's going to change how we define a city. And I'll give you an example. In a 30-meter cell, what we can capture as vegetation or built up is going to be very different than in a 10-meter cell. And so if you have a 10-meter, if you have that higher resolution, if you have greater detail, you're going to have more open space, perhaps. You're going to have a different definition of what areas are the parks, what's open, than you would in 30-meter data. And so that's sort of looking forward as we're using these newer data sets and getting greater accuracy. It changes then also those measures of that we're applying to the maps. Okay. The second measure, or the second data set, I should say, is always thinking about population. And the one thing that I've always liked about the Gerber method is that they really take into account how they're collecting the data and how they're linking it up to the urban extent data. And there's a couple of groups out there that have done this as well, because when you're not considering your population data with respect to the same cells, you can be measuring apples and oranges. And so that was just one thing that was a little bit unclear in Patrick's presentation on the NYU urban extent, was what boundaries they're using for the population, how that matches up. Because ultimately, we have so many problems collecting population data in terms of the districts, the level of detail, the definitional issues made by a certain country about their population data. All of those different things come to play. And I think we've come, again, to realize that some of our modeled population data sets, so world pop, seasons, global population of the world is another one, but some of these we're getting better and better at how we make those assumptions and actually model a population across the landscape. And so I really like how Gerber is very articulate on that note, on how they do it. So finally, that brings us to nighttime lights. And nighttime lights has always been this hugely valuable data set, but it always, to me, has been something that we need to use with, like I said, with a little bit of caution, just because of how differently cities are defined in that data, how cities look with respect to their luminosity, their illumination. One thing that I think people forget is the data set is 1 kilometer, but the actual original data is collected at a 2.2 kilometer cell. And so that blurring and sort of the pixels that turn on and off, part of that is due to that coarser resolution and then trying to fit it into a 1 kilometer grid. Okay, so we get this kind of rough approximation. But there's something else that goes on when we use nighttime lights data, and especially when we use it globally or across country boundaries. And that is, we take this very sort of Americentric, Eurocentric view of what a city is, that cities are lit up around the world the same way as we light our cities. And so, for instance, when I look at the nighttime lights data, Africa disappears, right? For certain years, Africa doesn't appear because those cities are not lit. It doesn't mean the cities are not there. They don't show up in that data. Now, of course, you could say, well, with respect to the economics, that makes perfect sense, right? These cities really didn't kind of come into the international scene in these early dates. But in another respect, you've also got some kind of characteristic quirks in this data set. So another example that I always love is that China, for instance, in the last couple decades has had a huge push to illuminate their cities, but also to illuminate their roads. So if you look at change across the nighttime lights data set in China, you actually see this huge expansion, but it's more a reflection of a particular policy that was put into place. And so that's kind of the caution of using that particular data. Again, so many different kind of different aspects and different thresholds that we're using. So I really enjoyed all of the conversation. And like I said, the transparency with how we're thinking about this. It does leave us with sort of this one big question of, okay, so what are we going to define globally? How do we look at these measures? How do we come up with something that says, what is urban extent globally? And then what are the populations globally? And do we have strong data sets for both, right? That have high levels of accuracy? Because the one thing that I would mention is thinking about accuracy in these Landsat-based maps, when you have a 70% accuracy and 80% accuracy, that puts huge error bars then on how we measure urban extent as well. And I think we can get much, much higher. At this point, we should be in the upper 90%. We should be able to look at a map of urban extent and say, yeah, when you use Landsat data and when I use Landsat data, we should get something fairly similar based on all the machine learning methods out there. So I think that part is valuable. And I think we've made some, like I said, some great progress. So I'm going to stop with my comments there. There was one comment or a question that I wanted to bring up because I saw a note on how do we define favelas and slums? How do we define these informal settlements? And I think there's been a great amount of work recently that these areas do show up in Earth observation imagery. They may not show up as lit, and they don't necessarily show up in the population information, but we do see them in satellite data. And even some of, when we were looking at the maps of Luanda, Dhaka, and Warsaw, Luanda and Dhaka especially, there were areas outside of the city, when you looked at the Google Earth maps, that sometimes were captured and sometimes were not in how they were delineating, how the different groups were delineating urban extent. So I think that sort of shows you the sensitivity that we need to be thinking about as well is not only the data sets, but then what we're including on those edges. So back to those measures that we're using of what gets included and what doesn't. So like I said, I will stop my comments there.
Okay, thank you very much, Anne-Marie. So I will be the second discussant. So what I want to do is to go back to each approach and give you some broad thoughts about each one of them and the pros and the cons, and then draw some conclusions from there. So the first thing I want to address is night lights. I think in what Juan presented, there's actually two parts. There's the tool or the underlying data, which is night lights, and the specific approach you take. At some level, I think Juan is a bit agnostic. He says, okay, I'm taking this because this is what people have taken before, whatever threshold of 50,000 and this and that, but that could actually be changed. That could be changed, again, to perhaps tailor that to specific purposes. So then the particular tool of night lights and satellite imagery is that, I mean, the big plus is that this is widely available, it's free, doing that sort of work doesn't impose a big computational burden unless you try to do something very, very specific with it, but otherwise it's very easy to use. The minus is that the cities you define, and this is a point that's actually made in one of the papers in our special issue, is that it leads to pretty coarse definition of cities, which, you know, those authors in that other paper, they try to distinguish what they call markets from the supermarkets, and they claim that from population data and from built-up data, you can get the markets, and from the night lights, you're going to get the supermarket, like these broader units. Which are going to be fine for many purposes, maybe not all of them, but at least for many purposes. Like Anne-Marie said, what I don't like about night lights is that there's a lot of heterogeneity over time and over space. So over time, she just talked about China. Over space, let me take another example. Belgium looks so much brighter than my native country, France. You know, I'm not resentful of that. Belgium looks so much brighter also because they're lighting up their highways in a way that France doesn't well completely, and you know, that's creating heating technologies and so on and so forth are going to create like big differences in the cross section, which are problematic. Then let me move to the degree of urbanization. I'm pretty down on that because this is this one size fits all, and we all need to adapt this definition. Otherwise, we're doomed and we're going to be stupid. And you know, I'm not a fan. First, I mean, the initial processing step, like 71% accuracy, is freaking low. I mean, when you do machine learning, you want to get high in the 90%. 71%, you know, is not very far from 50. I mean, that's not great. The second part that I don't like is, you know, you try to use population data, but the population data is pretty horrible. I mean, when you look at the details, you know, some countries haven't run a real census for many, many years. I mean, the last, well, to take an extreme example, where the last world census in the Lebanon was like in 1924. You will have also, it creates a huge amount of heterogeneity. So let me actually zoom in on World Pop, which is the one I know best. You know, World Pop has hundreds of thousands of units for the US. So, you know, you can get a population map that's going to be at least of night, of night residential world population map that is incredibly accurate. But in some countries, you know, you have pretty large countries with whatever 400 municipalities, and they will just, you know, just it's as good as random at some level. The third thing I don't like about the agreeable urbanization is all those thresholds and categories. I mean, what are the cities here? You know, in that case, you know, then you start criticizing on something as well. Oh, but you're not thinking about the right category and stuff. But you know, you have 6 or 7 of them. I mean, that's in that case, or maybe, you know, we should no longer be thinking about 12 categories, but be really explicit about that and actually have a scoring system. You know, I do think they have really counterfactual findings, like I said in my introduction. India, by their metrics, is more urbanized than the US, and I just don't think this is true, period. City results, like Soli highlighted, they really seem weird. I mean, is Dhaka suddenly becoming so much bigger and so much denser? Luanda, that was arguably wrong again, and so on and so forth. So I think this is really well problematic, and we should probably steer away from that and be really, really cautious when we use it. Urban extents, you know, what I really like is that here the data is being designed given the purpose that's at hand, which is trying to think urban expansion in a very precise way. Something which is both the pro and the con is that there's, you know, each city requires a lot of work. So there's hugely labor-intensive pre-treatment that needs to be done. What also I find to be a limitation is that the cities are given ex ante. You know, ideally, you should be looking at your data and extract the centers, extract the city without having to name them well beforehand. There are some questions. I mean, myself looking at urban transportation data, Soli's sample doesn't seem to be that different from my own significantly bigger sample of whatever 1,400 well cities. But I think there's more work to be done here. So, you know, putting all of that together, I think, you know, there are 2 ways to do that here. The first way is the broad but shallow type of approach of degree of urbanization of nightlights as presented by Juan versus the deep but narrow approach that Patrick presented us with, which is like we zoom into cities and stuff, hoping that our smaller subsets, because we cannot treat the whole world, it would be just too much work, is actually reasonable. There are big differences in what we've seen. I mean, looking at the results about the 3 cities, you know, does Dhaka have 6 million people or whatever, 15 million people? Have actually some delineation where Bangladesh is just one big city with 180 million people. So there are like big differences, you know, like Nightlights is saying that sub-Saharan Africa cities are not progressing well spatially, but increased by about 20% when in terms of population. Degree of urbanization is saying that it's about the same in terms of population, but the areas are increasing by 20 to 30% again for sub-Saharan Africa. Soli and what was presented by Patrick, the numbers are literally twice as high. So I think there's you know, there are big differences here. There's actually some work that Mark Roberts and my co-author Pierre-Philippe Combe are doing with the World Bank, trying to understand where those differences are coming from. Is that about the methods? Is that about the data? It actually looks like this is at least as much about the data being used in the methods, which is again well a bit scary, but given that I've been scathing about well data, well quality, that may not be so much of a surprise. Then I think there's something that we will have a hard time dealing with, and we will need to agree, well, to disagree. Well, again, surrounding in those cities, you have those suburban areas with declining population, gradients, which are pretty flat. And again, it's never going to be clear where you want to draw the line. There's no such thing as a natural discontinuity here. And again, reminding people that to delineate cities, you need to have a purpose. You need to have an underlying theory of cities. So going forward, and trying to advertise my work, given that I have a forum here, I'm advocating methodological seriousness. So I think we really need to try to minimize the number of thresholds, try to replace that by trying to be automatic, try to have that as automatic criteria and so on and so forth. The other thing that I would like people to do is don't do so much pre-selection, if you want to select stuff, do it ex post. Yeah, you're going to come up with a very long list, and maybe you don't want to look at places with 234 people and so on and so forth. But you can always select that ex post as opposed to ex ante. And also advocating for some data realism. I think population data is incredibly awful. Build up from data and imagery, I think is better. And I think this is what some of us have been using. So night lights, for all the issues, they may not be too bad either, keeping in mind all the caveats that both Anne-Marie and I have listed. So I'm going to stop here, and we should be moving to the questions from the audience. So should we look at questions on the chat, or should we take live questions?
I believe most of the questions have been answered by our panelists. So I don't know if maybe some of the participants would like to raise new questions, or if something that has already been asked, maybe some of the panelists would like to dive deeper into.
I have a general comment that occurred to me during the introductory remarks, which is that for all the evident importance in being able to measure cities, it's still not decisively agreed upon by some that cities are in fact a unique unit of analysis. And I think in that sense, as urbanists, our field is really in an interesting position, because I can't think of any other field of study where we're moving ahead with large, costly interventions that purport to address a thing that's called the city, while at the same time, there are many people who claim that cities are just part of a spectrum from rural to urban, and that there's no need to delineate these things and address them at all. So I don't know if any of the other participants have any comments on that, but from my perspective and in my work, cities are real. They exist as discrete units where certain economic activities and social activities are possible that aren't possible in other places. But I also recognize that our attempts at definition aside, this is something that is by no means undisputed. Maybe if anyone has any thoughts on how we can move toward at least resolving that core question, or at least exploring that core question, that in a way would point us in the direction of a definition of cities that could be more agreed upon.
I mean, Patrick, if I may, I both fully agree and fully disagree, in the sense that I think there's a need for discretization, either because we think that quite fundamentally there's this discrete object that's a city that's discretely well different from a rural area, which will depend on the sort of conceptualization you have, and some conceptualization will say yes and others will say no, but practically we need, I think, to discretize for two reasons. I mean, first, there's a lot of policies and interventions that indeed are going to be discretely about urban or rural, and we need to have them, we need to give them some sort of sense of what direction about where they're going, and whether or not they're actually allocating those very, very large sums of money rights. So that's pretty fundamental. Then, like all discrete, and also for a broader audience, like the broader audience, and we need to have this message that urbanization is important, that there's lots of things happening within cities, and this broader audience is thinking about the world in a 0-1 sort of way, right? There's urban and not urban, so we also need to address that, even though, again, there's not always a clear theory behind and stuff, but we need to have those headline numbers that hopefully make some sense. But again, the clear limitation of discretizing is that we have this continuum that goes from 0 to 1, and as I've been arguing, in suburban areas with a lot of some density, but not too much. And we need to draw the line somewhere. That's hard, and we can agree to disagree, because again, the one possible answer is to try to draw more lines, like degree of urbanization, and try to create more subcategories. But then, that's getting really confusing, and I don't think we may be gaining whatever, but we're certainly losing intellectual clarity for sure by doing that.
Well, I believe, well, thank you, Gilles and Patrick, for the final remarks. I believe for our audience, we have reached the end of the scheduled session. So I want to thank you, everyone, for joining us today. I want to thank you all for panelists and all of you attending. We kindly invite you to join our follow-up sessions. This is the first one on a 4-session series that we are hosting jointly with the Marron Institute and Building and Cities. Our next session would be in explanatory models of urban expansion, and that would take place on Thursday, October 7. We would be following up with more information on the topic. And yes, we look forward to hosting you soon again. Thank you, everyone.
Okay, thank you very much.
Thank you.
Thank you.
Thank you. Bye.